I want to start with something that happened in a seminar room at Princeton in 1965 that most people have never heard about. And that, I think, is one of the most consequential moments in the history of human thought. Not because of what was discovered that day. Nothing was discovered. No experiment was run, no calculation was completed, no paper was published. What happened was a question. A single question asked by a graduate student to his thesis advisor. A question so direct and so unsettling that the advisor sat with it in silence for a long moment before responding. And the response, when it came, changed the way a small number of physicists thought about the universe forever. The graduate student was Hugh Everett. The thesis advisor was John Wheeler. And the question, stripped to its essentials, was this: if quantum mechanics is the fundamental theory of everything, if it applies not just to electrons and photons, but to everything that exists, including the instruments that measure them, and the people who operate those instruments, and the planet those people live on, and the universe that planet inhabits, then what is the wave function of the universe itself? What is the quantum state of everything? And if that state exists, if there is a mathematical object that describes the complete quantum configuration of all matter and energy in the universe at any moment, then that object must contain you. Not as a metaphor, not as a philosophical abstraction, as a term in an equation, as a specific configuration in a specific superposition. Your existence right now, reading these words, is encoded in a mathematical object that has been evolving since before the Big Bang. And that object is not a description of the universe from the outside, it is the universe from the inside. That idea has a name. It is called the universal wave function. And it is, in my view, the most audacious and the most philosophically consequential concept in the history of physics. Not because it has been proven, not because we know how to write it down, not because anyone has solved the equations that govern its evolution, but because the logic that leads to it is almost airtight, because the alternative requires assuming that quantum mechanics stops applying at some scale that nobody has ever been able to identify, and because if it is correct, if the universal wave function is real, and the Schrödinger equation governs its evolution, then the implications for what you are and what the universe is are so radical that they make every other revolution in the history of science look like a gentle correction. I want to take you through this idea carefully, not quickly, not with the breathless compression that most popular accounts use when they touch on these topics. I want to take you through it the way I take students through it, step by step, making sure each piece is solid before building the next piece on top of it. Because the conclusion is so strange that the only way to trust it is to have followed every step of the argument yourself. Let me begin not with quantum mechanics, but with classical physics, with the world as Newton saw it in Newtonian mechanics. The state of a physical system at any moment is completely described by the positions and velocities of all its constituent particles. If you know where every particle is and how fast it is moving in what direction, you know everything there is to know about the system at that moment. And Newton's laws, the equations of motion, tell you exactly how that state evolves in time. Given the state at one moment, the equations determine the state at every future moment and every past moment with absolute precision. The universe, in Newton's picture, is a machine, a deterministic machine that runs according to fixed rules, whose future is completely determined by its present, and whose present completely determines its past. This picture has a particular feature that I want you to hold on to, because it will become important. In Newtonian mechanics, the state of the universe is a list of numbers, positions and velocities for every particle. The equations of motion are rules for updating that list. The universe, from Newton's perspective, is a very long number that changes in a very specific way over time. Now let us move to quantum mechanics. And the first thing I want to say about quantum mechanics is that it does not simply replace the Newtonian list of positions and velocities with a different list. It replaces the concept of a definite state with something fundamentally different, something that has no classical analog, something that requires an entirely new conceptual framework to even describe. In quantum mechanics, the state of a physical system is not a list of definite values for position and velocity and other physical quantities. It is a wave function, a mathematical object, usually written with the Greek letter psi, that assigns a complex number, a number with both a real and an imaginary part, to every possible configuration the system could be in. The square of the magnitude of that complex number gives the probability of finding the system in that configuration if you measure it. But, and this is the critical point, before measurement, the system is not in any one of those configurations. It is in a superposition of all of them simultaneously, with each configuration weighted by its probability amplitude. This is not just a statement about our ignorance. It is not saying that the system has a definite configuration and we just do not know which one. The experiments that test Bell's inequalities, which we discussed in an earlier video, demonstrate that the superposition is real. The particle is genuinely in multiple configurations at once, not secretly in one, actually in multiple. The wave function evolves in time according to an equation called the Schrödinger equation, named for the Austrian physicist Erwin Schrödinger, who wrote it down in 1926. The Schrödinger equation is deterministic in exactly the same way Newton's equations are deterministic. Given the wave function at one moment, the equation tells you the wave function at every future and past moment with complete precision. The wave function of a quantum system evolves smoothly, continuously, deterministically, according to fixed mathematical rules. But here is where the story gets complicated. When you measure a quantum system, when you interact with it in a way that extracts definite information, something appears to happen that the Schrödinger equation does not describe. The superposition of multiple configurations collapses into a single definite outcome. The particle that was in multiple places at once is suddenly in one place. The electron, whose spin was both up and down, is suddenly either up or down. The measurement produces a definite result, and the wave function after the measurement is the wave function of a system in that definite result, not the original superposition. This collapse is the central mystery of quantum mechanics. It is called the measurement problem. And the measurement problem has never been solved, not in 100 years of trying, not despite the most sophisticated theoretical and experimental efforts in the history of physics. The problem is this: the Schrödinger equation evolves wave functions smoothly and continuously without ever collapsing them. Measurement, according to every experimental observation we have ever made, produces definite outcomes. But if measurement is itself a physical process, if the measuring device is made of atoms that obey quantum mechanics, then the measuring device should also evolve according to the Schrödinger equation. And the Schrödinger equation does not produce collapses. So either measurement is not a physical process, which seems absurd, or the Schrödinger equation does not apply to measuring devices, which requires explaining why and where quantum mechanics stops, or collapse does not really happen, and what we interpret as collapse is something else entirely. The standard interpretation of quantum mechanics, the Copenhagen interpretation developed by Niels Bohr and Werner Heisenberg, essentially takes the first option and declares that measurement is special, that it cannot be described by quantum mechanics, that the wave function is not a description of physical reality, but a calculational tool for predicting the probabilities of measurement outcomes. The Copenhagen interpretation is operationally powerful. It tells you how to use quantum mechanics to make predictions, and those predictions are extraordinarily accurate. But it is, as a physical theory, profoundly unsatisfying, because it draws a line between the quantum world and the classical world of measurements and observers without ever explaining where that line is or why it exists. Hugh Everett sitting in that seminar room in 1965, was dissatisfied with the Copenhagen interpretation for exactly this reason. If quantum mechanics is fundamental, he thought, if it applies to everything, then it applies to measuring devices and observers and planets and the universe itself. There is no line. There is no classical world that stands outside the quantum description and causes collapses. There is only the wave function and the Schrödinger equation. And if there is only the wave function and the Schrödinger equation, then what we interpret as collapse must be something that happens within the wave function, not to it. Everett's insight was this: when a quantum system in a superposition interacts with a measuring device, the Schrödinger equation does not collapse the superposition. It entangles the system with the device. The result is a superposition of different device states, each correlated with a different system state. The device has not measured one definite value and collapsed the wave function. The device has become quantum mechanically entangled with the system, and the combined state of system plus device is a superposition in which the device is pointing to value A in one term and pointing to value B in another term. Both terms are present in the wave function. Both are real. Neither collapses. Now apply this to the observer. The observer looks at the device. The observer's brain interacts with the device. The Schrödinger equation says the observer becomes entangled with the device, which is entangled with the system. The result is a superposition in which the observer sees value A and the observer sees value B. Both are present in the wave function. Both are real. From the perspective of the observer, in the A branch of the superposition, they saw a definite outcome. They saw A. They experienced what looks like collapse to A. They have a memory of seeing A. Their subsequent behavior is that of an observer who measured A. From the outside, from the perspective of the whole wave function, no collapse occurred. The superposition continued to evolve according to the Schrödinger equation, with both branches present. This is the many worlds interpretation, or the Everett interpretation, or relative state formalism. The world does not collapse when measured, it branches. Every quantum measurement, every interaction that could go multiple ways produces a branching of the wave function into multiple terms, each term containing a different outcome, each term equally real, each term inaccessible from the others. Because quantum decoherence, the interaction of quantum systems with their environments, makes the branches unable to interfere with each other on any practical timescale. You are a branch, not a specific branch that was singled out by some collapse mechanism, a branch that exists within the universal wave function as one of an enormous, perhaps infinite, number of branches, each containing a slightly or dramatically different version of the history of the universe. Now I want to slow down here, because I know how this sounds, and I know what the immediate objection is. The many worlds interpretation sounds like it is multiplying entities beyond necessity. It sounds like it is proposing an enormous, unobservable, unfalsifiable plurality of universes for the sole purpose of avoiding the discomfort of collapse. It sounds like the most extravagant ontological commitment in the history of science. Why should we take it seriously? The answer is that the many worlds interpretation does not add anything to quantum mechanics. It removes something. The Copenhagen interpretation adds the collapse postulate, an additional rule beyond the Schrödinger equation that says wave functions collapse upon measurement. The many worlds interpretation removes that postulate. It says the Schrödinger equation is everything. There is nothing else. The wave function evolves according to the Schrödinger equation and nothing else, always, without exception. The multiplicity of worlds is not an addition, it is a consequence. If the Schrödinger equation is everything, if there is no collapse, then the branching structure follows inevitably from the mathematics. The other branches are not postulated, they are derived. The universe is not multiplied. The universe is described more completely and the more complete description turns out to contain more than we previously admitted. This is exactly analogous to the situation with special relativity. Before Einstein, physicists believed that the present moment was universal, that simultaneity was absolute, that there was a single shared now for all observers. Einstein did not add anything to make simultaneity relative. He removed the assumption of absolute simultaneity and showed that Maxwell's equations, the equations of electromagnetism, were consistent with the relativity of simultaneity. The removal of an assumption revealed a more complete picture. The many worlds interpretation does the same thing for quantum mechanics. Now, let me build toward the concept of the universal wave function, because this is where the implications for your existence become direct and specific. If quantum mechanics applies to everything, if the Schrödinger equation governs the evolution of every physical system without exception, then there is a quantum state for the universe as a whole. A wave function that assigns probability amplitudes to every possible configuration of all the matter and energy in the universe, not just the electron in the lab, not just the measuring device, not just the laboratory, not just the Earth, not just the solar system, not just the galaxy. Everything, all of it, simultaneously, in a single mathematical object that encodes every possible state of every possible component of everything that exists. That object is the universal wave function. And I want you to sit with what it means for it to exist. The universal wave function is not a description of the universe from some external perspective. There is no external perspective. The universe is everything. There is no outside from which to observe it. The universal wave function is the universe describing itself in the only language that physics has found adequate to the task. It is the complete quantum state of everything, evolving according to the Schrödinger equation, never collapsing because there is no external observer to cause a collapse, branching continuously as quantum interactions occur throughout its volume, and you are in it. Not in a vague or metaphorical sense, in a precise mathematical sense. The configuration of matter and energy that constitutes your body, your brain, your memories, your experiences, your consciousness, if that is a physical process, is encoded in the universal wave function. The specific pattern of neural firing that constitutes your reading these words right now, the specific arrangement of atoms in your body, the specific quantum state of every particle in your brain, is a component of a term in the universal wave function. A specific branch in the branching structure that the Schrödinger equation has been producing since the initial state of the universe. The equation contains you, not as a symbol or a label, as a configuration, as a term, as a part of the mathematical structure that is, if the many worlds interpretation is correct, the most complete description of physical reality that exists. Now I want to go further back, before the Big Bang, before the universe as we know it, because the universal wave function, if it exists, must have an initial condition, a starting state from which the Schrödinger equation began evolving. And the question of what that initial condition is and where it came from is one of the deepest questions in all of physics. Here is where we enter the territory of quantum cosmology, the attempt to apply quantum mechanics not just to systems within the universe, but to the universe itself, including its creation. This program was developed most seriously by Stephen Hawking and James Hartle in the 1980s, and it produced one of the most audacious proposals in the history of cosmology, a proposal for the wave function of the universe at the beginning of time, a proposal that has come to be known as the Hartle-Hawking no-boundary proposal. The central idea of the Hartle-Hawking proposal is deceptively simple to state and extraordinarily deep to understand. In ordinary quantum mechanics, you calculate the probability of a system going from one state to another by summing over all possible histories, connecting the initial and final states. each history contributes a complex number to the sum, and the sum of all contributions gives you the probability amplitude for the transition. This is Feynman's path integral formulation of quantum mechanics, one of the most beautiful and powerful formulations of the theory. Hartle and Hawking applied this approach to the universe as a whole. They asked, what is the probability amplitude for the universe to be in a given state now? And they answered it by summing over all possible four-dimensional space-time geometries that have that state as their boundary. But here is the crucial twist. They did not require the histories to have an initial boundary. They summed over compact geometries, geometries that have no edge at the beginning of time, geometries that are closed in the time direction, the way the surface of a sphere is closed in the spatial directions. The result is a specific wave function for the universe, the Hartle-Hawking wave function, that predicts the probability of different possible initial states of the universe, and therefore the probability of different possible histories, including histories that lead to universes like ours. The Hartle-Hawking wave function is not derived from prior conditions. It is self-contained. It is the quantum state of the universe that arises from nothing, not nothing in the sense of empty space, but nothing in the sense of no prior time, no prior boundary condition, just the geometry of space-time closing smoothly at the beginning, the way the surface of the Earth closes smoothly at the South Pole. There is no south of the South Pole. There is no time before the beginning in the Hartle-Hawking proposal. The beginning is not a boundary. It is a smooth point in a compact geometry, as natural and as necessary as any other point. The universe did not begin at a moment in time. Time itself began with the universe, as part of the universe, as a dimension of the four-dimensional geometry that the wave function describes. And the wave function that arises from this no boundary condition, the Hartle-Hawking wave function, has been running, evolving, branching according to the Schrödinger equation since that beginning, not since a moment in time. Since the geometry itself became the kind of geometry in which time is a well-defined concept, it has been running for 13.8 billion years of cosmic evolution. It has been running through the formation of the first stars, through the supernova explosions that seeded the interstellar medium with heavy elements, through the formation of the solar system, through the emergence of life on Earth, through the evolution of nervous systems capable of processing information, through the emergence of consciousness, through the development of language and mathematics and physics. All of that, the entire history of the universe as we understand it, is a single branch of the universal wave function, selected not by any external agency and not by any collapse, but by the fact that you are in it, that you are a component of it, that the configuration of matter that constitutes your experience of reading these words is a term in the mathematical structure that has been evolving since before time as we know it began. I want to pause here and acknowledge something. I have been building an argument that has a lot of pieces, and I want to be honest about which pieces are solid and which are more speculative. The solid pieces, quantum mechanics is our most successful physical theory. The Schrödinger equation governs the evolution of quantum states with extraordinary precision. The measurement problem is real and unresolved. The many worlds interpretation is a legitimate and internally consistent solution to the measurement problem that is taken seriously by a significant fraction of working physicists, including some of the most technically sophisticated people in the field. David Deutsch, who invented quantum computing, is a committed Everettan. Sean Carroll has written extensively and carefully in defense of the many worlds interpretation. The decoherence program, which explains how quantum superpositions effectively separate into non-interfering branches, has been developed with considerable mathematical rigor and experimental support. The more speculative pieces. We do not have a complete theory of quantum gravity. The Hartle-Hawking no-boundary proposal is a specific proposal within quantum cosmology that is elegant and influential, but not proven. The application of quantum mechanics to the universe as a whole requires extrapolating the theory beyond any regime it has been directly tested. The universal wave function is a concept that follows from the logic of quantum mechanics applied universally, but we have never observed the universal wave function, and we have no direct evidence for it beyond the success of quantum mechanics in every domain we have tested. What I'm not doing is claiming that the many worlds interpretation is definitely correct, or that the Hartle-Hawking proposal is definitely the right description of the initial state of the universe. What I am doing is tracing the logic of where quantum mechanics leads, if you take it seriously as a fundamental theory, and showing that the destination is a picture in which the universe is described by a single mathematical object evolving according to a single equation that contains within it every possible history, including the one that contains you. Now let me take you somewhere that the physics papers rarely go, because I think this is where the story becomes most important. I want to ask what it means concretely and physically for you to be a term in the universal wave function. The universal wave function is a superposition of all possible configurations of all matter and energy in the universe. Each term in the superposition is a complete history of the universe, from its initial state to its final state, including every detail of every object and every event in that history. The term that contains you, the specific branch of the wave function in which you exist, is a complete history that includes the formation of the solar system, the emergence of life on Earth, the evolution of your species, your birth, every experience you have ever had. And this specific moment of your reading these words, that history is not arbitrary. It was not randomly selected from all possible histories. It is the history, it is because of the physical laws that govern the evolution of the wave function, and because of the initial conditions encoded in the Hartle-Hawking wave function, or whatever the correct initial condition is. Every detail of your existence, every physical fact about you follows from those laws and those initial conditions. Not in the sense that it was predetermined in a simple clockwork sense, because quantum mechanics is genuinely probabilistic in a way that classical mechanics is not, but in the sense that the probability distribution over all possible versions of you, all the terms in the universal wave function that contain something like you, is determined by the initial state of the universe and the laws of quantum mechanics. You are, in this sense, a prediction of the universal wave function. Not a specific prediction, because quantum mechanics does not make specific predictions about individual outcomes, but you fall within the probability distribution. You are one of the outcomes that the wave function assigns non-negligible probability to. You are, in the language of quantum cosmology, a typical observer in a typical branch of a typical universe. And the fact that you are typical rather than atypical is itself information about the initial conditions and the laws. This connects to something called the anthropic principle, which gets misused so often that I want to handle it carefully. The anthropic principle, in its weak form, simply notes that the universe we observe must be compatible with the existence of observers who observe it. This sounds trivially true and is sometimes dismissed as circular reasoning, but it has real content in the context of quantum cosmology. The universal wave function contains branches in which the universe looks like ours and branches in which it looks very different. In branches where the constants of physics are too different from their values in our branch, structures like atoms, stars, planets, and biological organisms cannot form. Those branches exist in the wave function, but they do not contain observers. The branches that contain observers are, by selection, branches where the physics is compatible with the existence of observers. This is not a complete explanation of why the constants of physics have the values they have. It is an observation about the relationship between the structure of the universal wave function and the kind of universe that observers find themselves in. And it suggests that the question, why does the universe have these specific laws and constants, is not purely a question about the initial state. It is partly a question about which branches of the universal wave function contain the kind of structures that ask the question. Now I want to take you to what I find to be the most profound implication of the universal wave function. The implication that I think deserves more attention than it gets, and that I have been building toward since the beginning of this conversation. If the universal wave function is real, if it contains everything, if it has been evolving since before the Big Bang, then it contains not just the physical configurations of matter and energy, it contains the informational patterns that constitute minds, it contains the structures that process information, that form memories, that generate what we call experience. It contains, if consciousness is a physical process, consciousness itself. I want to be careful here, because the relationship between physics and consciousness is one of the most contested areas in all of science and philosophy. I am not claiming that the universal wave function solves the hard problem of consciousness, the question of why physical processes produce subjective experience. That problem remains open, and I do not think any interpretation of quantum mechanics closes it. What I am claiming is something more specific. If consciousness is a physical process, if it is implemented in the physical configuration of matter and energy in a brain, then that physical configuration is a term in the universal wave function. The consciousness, whatever it is implemented in something that is mathematically described by the wave function. The experience you are having right now is happening in a physical system whose complete quantum state is a component of the universal wave function. This means something concrete. It means that the boundary between you and the universe is not where it seems. The atoms in your body are quantum mechanically entangled, in principle, with the atoms around you, and those atoms are entangled with atoms further away, and so on, in a web of quantum correlations that ultimately connects everything in the observable universe. The separateness of objects, the apparent independence of you from your environment, is an emergent feature of decoherence, the process by which quantum entanglement with a large environment, effectively classical, eyes the behavior of macroscopic objects. You feel separate from the universe. You experience yourself as a localized entity with a boundary at your skin. But the wave function does not have that boundary. The wave function is continuous. The entanglement is real. The separation is an approximation. You are not an observer standing outside the universe looking in. You are a pattern within the universal wave function that has become complex enough to model itself, to represent its own existence, to ask questions about the structure it is part of. The universe, through the specific branch of its wave function that contains you, is becoming aware of itself. Not for the first time, probably. There are presumably many other branches containing many other configurations of matter capable of self-awareness, but here, in this branch, at this moment, one specific configuration of quantum fields is doing the particular thing that we call understanding physics. Let me follow one more thread before we approach the end of this conversation, because I think it is the thread that connects everything I have said to the question you are probably asking, which is, what does any of this mean for how I live? The universal wave function contains all possible histories of the universe. In the Everett interpretation, all those histories are equally real. The branch in which you took a different job 5 years ago exists. The branch in which you said something different in a crucial conversation exists. The branch in which the events that shaped your life went differently exists. These are not fantasies or might have beens. They are, in the Everett interpretation, actual branches of the universal wave function, actual terms in the mathematical object that describes physical reality, as real as the branch you are in now. I find this both liberating and vertiginous. Liberating because it means that the paths not taken were not lost. They exist. The versions of you who made different choices exist in different branches, living different lives that diverged from yours at specific quantum branching points. Vertiginous because it means that the you in this branch, the you that is reading this, is not the only you. You are one branch of a much larger structure. The sense of being a unique individual with a single continuous history is real within your branch. But it is not the complete picture. This might seem to diminish the significance of your particular existence, the particular branch you happen to be in. Why does it matter what happens in this branch if other branches exist in which different things happen? This is the question that the many worlds interpretation inevitably raises, and I think it is one of the most interesting questions in the intersection of physics and ethics. My honest answer is that I do not think it diminishes significance. I think it relocates it. The significance of your choices, your actions, your experiences is not diminished by the existence of other branches in which you chose differently. The branch you are in is the branch that you are in. The experiences you have in this branch are the experiences that constitute what it is to be you in the only sense that you have direct access to. The other branches are real, but they are not accessible from here. They do not diminish the reality of what happens here. They are simply more of the real, distributed across the structure of the universal wave function in a way that the quantum mechanics demands. What the many worlds interpretation does suggest, I think, is a different relationship to regret. If the paths not taken exist in other branches, if the choices you did not make are being lived out in parallel histories, then regret for specific decisions becomes complicated. Not impossible. The branch you are in is still the only branch accessible to you, and the consequences of decisions in this branch are real and present and matter. But the absolute finality of unchosen paths, the sense that the road not taken is simply gone, is not accurate within the many worlds framework. It is taken in another branch, by another you who is as real as you are. I want to return now to the equation itself, because I have been circling around it and I want to land on it directly. The equation I have been describing, the Schrödinger equation applied to the universal wave function, is not just one equation among many. It is, if the many worlds interpretation is correct, the master equation, the single mathematical rule that governs the evolution of everything. Everything that exists, every particle, every field, every force, every structure, every mind, every experience, every history is a solution to this equation operating on the initial state of the universe. The equation is not complicated in its form. The Schrödinger equation, written in full generality, states that the time derivative of the wave function is proportional to the Hamiltonian operator acting on the wave function. The Hamiltonian encodes all the energy and all the interactions in the system. For the universal wave function, the Hamiltonian encodes all the energy and all the interactions in the universe. It encodes gravity, which we do not yet know how to incorporate into quantum mechanics correctly. It encodes the strong force and the weak force and electromagnetism. It encodes the interactions between every particle in the universe and every other particle. It encodes, if consciousness is a physical process, the dynamics of mind. We cannot write this equation down explicitly because we do not know all the terms in the Hamiltonian. We do not have a complete theory of quantum gravity. We do not know the correct way to combine quantum mechanics and general relativity. We do not know whether the standard model of particle physics is the final word on the fundamental fields and forces or an approximation to something deeper. The equation exists in principle. We do not have it in practice. But its existence in principle is not trivial. It is a statement about the structure of reality. It is a statement that there is a single mathematical object that contains everything. And here is what I want to say about your relationship to that equation. You did not choose to be a solution to it. No configuration of matter chooses to exist, but you are a solution to it. A specific, particular, historically contingent solution that arose from specific initial conditions through specific evolutionary processes over 13.8 billion years of cosmic history. The solution is extraordinarily complex. The solution is self-aware. The solution is asking questions about the equation that produced it. That is, I think, one of the most remarkable facts in the history of the universe. Not remarkable in a sentimental sense, remarkable in a precise physical sense. The equation has been running since before time as we know it began. It has produced, in this branch, at this moment, a configuration of matter that can look back at the equation and ask what it is. A configuration that can derive the Schrödinger equation from experimental observations. A configuration that can construct the concept of the universal wave function and reason about its implications. A configuration that can sit here in this particular arrangement of atoms on this particular planet and understand, at least partially, the mathematical structure that produced it. The universe has, in you, acquired the ability to understand itself. Not completely, not without error, not in a way that answers all the questions, but genuinely, really, in the only way that understanding is possible, which is from the inside, from within the wave function, from a configuration that is itself a part of the structure it is trying to comprehend. There's a philosophical tradition that says self-reference is a source of paradox, that a system cannot fully describe itself, that the map can never be the territory. Gödel's incompleteness theorems are the mathematical expression of this tradition, and there is something to it. The universal wave function, if it could be written down, would be a description of the universe, including the description, a map that includes the map, a representation that represents itself. But I think the paradox, while real, is also a source of wonder rather than just limitation. The fact that the universe can, in some branches of its wave function, contain configurations that model the universe, that represent its structure, that derive its equations, is not a problem to be solved. It is a feature to be marveled at. It is the universe achieving something that inanimate configurations of matter cannot achieve. It is the universe becoming aware of the equation that runs it. You are that awareness, not all of it, not a privileged version of it. One branch, one configuration, one term in the universal wave function that is right now processing these ideas in the particular way that your particular neural architecture allows. Other configurations and other branches are processing different ideas or no ideas at all. But this one, the one that is you in this moment, in this branch, is part of the universe's ongoing project of understanding itself. And the equation that makes that possible has been running since before the Big Bang. I want to close with something that I think is the most honest thing I can say about all of this. The universal wave function, if it exists, is not something you can see or touch or directly observe. It is a mathematical object inferred from the success of quantum mechanics and from the logic of taking that success seriously. The many worlds interpretation is not proven. The Hartle-Hawking proposal is not proven. Quantum cosmology is not a finished science. The connection between the universal wave function and consciousness is not established. The hard problem of consciousness is not solved. What is established is that quantum mechanics is real, that it is our most successful physical theory, that it describes a universe in which the concept of a definite state before measurement is not fundamental, that the solution to this puzzle either requires an arbitrary boundary between quantum and classical, or allows the quantum description to extend to everything, and that if the quantum description extends to everything, the universe is a wave function and you are a term in it. That is the minimum that honesty requires me to say. And it is enough. It is enough to change the question from what am I to what configuration am I? From where do I fit in the universe to how does the equation that describes the universe describe me? From why do I exist to what does it mean that the universe in this branch has produced something capable of asking why. These are not questions I can fully answer, but they are the right questions. They are the questions that the physics is pointing toward. And the fact that a configuration of matter that is you can ask them, can hold them, can sit with them, is itself one of the most extraordinary solutions the equation has ever produced. Go outside tonight. Look at the stars. The light reaching your eyes has been traveling for years, decades, centuries. It originated in nuclear processes governed by the same Schrödinger equation that governs the atoms in your eyes. The information it carries, the photons that are striking your retina as you look up, are quantum systems entangled with the atoms that produce them in stars light years away. The universe is not separate from you, observed from a distance. You are part of the same wave function as those stars, connected not by any mystical thread, but by the same equation, the same physics, the same mathematical structure that has been evolving since before the Big Bang and that will continue evolving long after every star in the sky has burned out. The equation contains your entire existence. And your existence in this branch, at this moment, is one of the most complex and self-aware solutions that equation has ever generated. That is not a small thing. That is what it means to be here. If this landed for you, if it changed something in the way you see yourself in relation to the universe, I want to hear it in the comments. Tell me what piece of this you find most difficult to accept and what piece you find most natural. Tell me what the universal wave function means to you. These conversations are how the ideas develop, how they get tested against the reactions of people encountering them for the first time, how they get better, and subscribe if you want to keep going deeper. Because we have only just started